So now I come to introduction part. Uh, uh, Cancer is well-known example since it is so difficult to get precise medicine to malignant nanoparticles. Medicine delivery mechanism may help alleviate this issue to some degree. In comparison to free medication formulation, those based on nanoparticles, that is called NPs, have the potential for increased therapeutic effectiveness and decrease the adverse effect. And methodology, we use the materials including fetal bovine serum, glucose modified fecal medium, and antibiotic, antimyotic 4,6 diamidino to phenylenediol. This is called DAPI, trypsin, and other chemicals we have to use there. For MTT, in vitrogen also we have to use there. And the result is for first characterization of D block PEG PCl polymer. It was possible to determine the structure, chain length, and molecular distribution of the PEG PCl diblock copolymer. Nanoparticle size, distribution, and other features may not be repeatable if the polydispersity of the produced polymer is significant. Hence, 1H, TR, DSC, and GPC were used to completely characterize the polymer PG about 5 and PCL blocks can be identified in 1H NMR spectra. As we can see in the table, the GPC analysis of the polymer. Second one is polymer metals made by operating the solvent. The TC was gradually to the gas while the polymer and medication were dissolved. During the heating process, the solvent evaporates and medication precipitates inside the cells. And they are somewhat spherical in shape and measured between 50 and 80 nm diameter in size, seen in the given below figure. So DLC measurements could measure size to the somewhat larger than those obtained by TEM. Yeah, as mentioned before, this is because the PEG and PCl polymer chain have a low polydispersity. So third one is in vitro studies, physiochemical characterization, CPT and VP. So we said CPT loaded nanoparticles and the lipophilic drug mostly sequestered inside the vesicles membrane as per the previously published method. In the introduction, we discussed some of the issue with the proposed method of delivering the hydrophobic medicine directly into the lipid bilayer. To get around these disadvantages, we envisioned a hybrid polymeric natural vesicle system that would not be only provide the stealth coating of RBC but also protect the drug in the natural state by enhancing the interacting of the drug with a polymeric micelles in the core of the RBC vesicles that were prepared after loading the drug into the polymer at mass ratio, weight by weight, ranging from 1 is to 1 to 10 is to 1. The encapsulation efficiency was determined using centrifugation. To do this, we measured the CPT concentration of suspended micelles and use centrifugation at 1000 G to selectively precipitate the unencapsulated medication at 1 is to 1 PEG PCl is to CPT ratio only managed to encapsulate 15% of the drug, as we can see the figure. So now in vitro studies, cell uptake and toxicity were investigated in murine lung cancer A549 cell lines after comprehensive defined red blood cells membrane coated polymeric micelles nanodrug carriers and evaluating their release properties. So Nile red and insoluble in water dye was loaded onto the polymeric micelles and used in investigations of cellular absorption, that is NR. Fluorescent microscopy revealed small red patches in the cytoplasm with the DAPI stained nuclei appearing blue, as we can see in the figure. As the polymeric core encased the dye entirely, the bright cytoplasmic color indicate efficient vesicles endocytosis. So conclusion is that free CPT was shown to be very toxic, causing extensive damage to the liver and kidney, intestinal toxicity, and an inability to forestall cancer-induced weight loss due to cardiopulmonary dysfunction. Most importantly, it was easily flushed out of the body, which accounted for its weak tumor suppressing and overall life-threatening effects. By first putting it into the polymeric micelles and then coating it onto the RBC's membrane. Its therapeutic potential may be considered increased PCL's hydrophobic core shielded CPT from hydrolysis, while RBC membrane coating added steel both of the prolonged CPTs stay in the plasma and increased in tumors accumulation. So, hence, the nanovesicles platform described in this chapter is an improved version of the one mentioned in the chapter 2, with a larger coating capacity to encapsulate CPT, considerable slower release kinetics, and substantially better control over drug hydrolysis. It has potential for future investigation as a component of dual treatment, with the goal of reducing the total drug dose while maintaining and or improving therapeutic results compared to the single chemotherapy. And these are the references we have used while preparing this research paper. Thank you so much. Thank you, all panel members and president and my teachers and professors. Thank you so much.
Okay, thank you so much for your presentation, sir. So, is
Thank
there any
you.
question from academician and researchers point? I think there is no question. Thank you so much, sir, for your kind presentation. Thanks a lot.
Welcome. Welcome.